Close your eyes for a moment and imagine a morning where the sun rises just like every other day. Birds start flying, cities wake up, oceans shimmer, and life continues normally. But deep inside the core of that same sun, a silent countdown is already running. A countdown that will one day erase oceans, burn mountains, evaporate the atmosphere, and completely wipe out every form of life that ever existed on Earth. The sun is not just a life-giving star. It is also a cosmic time bomb. And today, we will understand when and how the sun will destroy life on Earth, step by step, with real physics, real chemistry, and real astronomy. This is Infinite Cosmos. The sun was born around 4.6 billion years ago from a massive cloud of hydrogen gas and cosmic dust. Under gravity, this cloud collapsed and compressed until temperatures and pressures in the center became so extreme that nuclear fusion began. Hydrogen atoms started colliding with such enormous energy that they fused together, forming helium, and in the process, releasing gigantic amounts of energy. This is the fundamental engine of the sun. Every single second, around 600 million tons of hydrogen are converted into energy. That energy escapes as light and heat, traveling 150 million kilometers to Earth, making life possible. Right now, the sun is in what scientists call the main sequence stage, the most stable phase of a star's life. In this phase, the balance between gravity pulling inward and nuclear energy pushing outward remains stable. But this balance is temporary. As hydrogen fuel in the core slowly decreases, fusion becomes less efficient, forcing the core to contract under gravity. This contraction increases the temperature and pressure even more, making fusion reactions more intense. As a result, the sun slowly becomes brighter over time. Most people imagine the sun as constant and unchanging. But in reality, its brightness increases by about 10% every 1 billion years. That small percentage may sound harmless, but for Earth, it is catastrophic. Earth exists in a very narrow zone called the habitable zone, where liquid water can exist on the surface. Our planet sits at just the right distance, receiving just enough energy to maintain oceans, atmosphere, and complex chemistry. Even a small change in solar energy can destroy this balance. In about 1 billion years from now, when the sun becomes roughly 10% brighter, Earth's average temperature will rise by around 10 to 15 degrees Celsius. This change alone will completely destabilize Earth's climate system. Heat waves will become permanent, glaciers will melt completely, sea levels will rise dramatically, and ocean currents will collapse. But the most dangerous effect will be on the carbon cycle. Plants depend on carbon dioxide to perform photosynthesis, producing oxygen. As temperature rises, chemical weathering of rocks accelerates, removing carbon dioxide from the atmosphere. Less carbon dioxide means plants struggle to photosynthesize. As plant populations collapse, oxygen levels begin to fall. Within a few million years, oxygen concentrations will drop so low that complex life forms, including humans, animals, birds, and insects, will no longer survive. Slowly, forests disappear, ecosystems collapse, and mass extinction sweeps across the planet. Earth becomes dominated only by simple microorganisms, bacteria, and extremophiles that can survive extreme heat and low oxygen. As the sun continues to brighten, surface temperatures will cross the boiling point of water. Oceans, which hold 97% of Earth's water, will begin evaporating at an accelerating rate. Massive quantities of water vapor will fill the atmosphere. But water vapor is also a powerful greenhouse gas, trapping more heat and causing further warming in a runaway feedback loop. Eventually, the upper atmosphere becomes saturated with water vapor. High-energy ultraviolet radiation from the sun breaks water molecules apart into hydrogen and oxygen. Hydrogen, being extremely light, escapes into space, never to return. Oxygen reacts with surface rocks, oxidizing the crust. Over millions of years, Earth permanently loses its oceans. Rivers dry up, clouds vanish, rain stops forever, and the planet becomes a barren, cracked desert world. At this stage, Earth will closely resemble Venus, with crushing atmospheric pressure, extreme heat, and no liquid water. Life as we know it will be impossible. Only heat-resistant microbial life deep underground or in extreme environments may persist for some time. But even they are living on borrowed time! As temperatures continue rising, Earth's surface becomes increasingly hostile. Chemical reactions accelerate, organic molecules break apart, and biological processes collapse. The once vibrant blue planet slowly transforms into a lifeless, scorched rock drifting silently through space. Around 5 billion years from now, the sun will reach the most dramatic phase of its life, the red giant stage. By this time, hydrogen in the core will be nearly exhausted. Without sufficient fusion to counter gravity, the core collapses inward, heating up to incredible temperatures. This triggers fusion of helium into heavier elements, like carbon and oxygen. Meanwhile, the outer layers of the sun expand enormously. The sun's radius will increase by over 100 times, becoming so large that it will engulf the orbits of Mercury and Venus. Earth will either be swallowed directly by the expanding sun or be heated so intensely that its surface will vaporize entirely. As the sun expands, Earth's surface temperature will exceed 2,000 to 3,000 degrees Celsius. All remaining rocks will melt. Mountains will flow like liquid. The crust will disintegrate into magma. Any remaining atmosphere will be stripped away. The planet's very structure will collapse. If Earth is engulfed, it will spiral inward, torn apart by tidal forces, and ultimately evaporate inside the sun's blazing outer layers. The planet that once hosted oceans, forests, animals, and civilizations will be reduced to cosmic dust. Eventually, the sun will shed its outer layers into space, forming a beautiful but deadly planetary nebula, glowing in brilliant colors across the cosmos. At its center, the remaining core will become a white dwarf, a dense stellar remnant about the size of Earth, but containing nearly half the sun's original mass. This white dwarf will no longer produce energy through fusion. It will slowly cool over trillions of years, fading into darkness. The solar system will become a cold graveyard, filled with frozen planetary remnants and drifting debris. This entire transformation is not science fiction. It is a precise prediction based on stellar physics, nuclear fusion equations, gravitational dynamics, and observational data from countless stars across the universe. We have observed stars of similar size and mass to the sun at every stage of this evolutionary process. The fate of Earth is sealed by the laws of physics themselves. But could humanity escape this destiny? Theoretically, yes. Over the next millions of years, if civilization survives long enough, humans could develop technologies that allow interstellar travel, artificial habitats, and star-scale engineering. One idea is the Dyson Sphere, a colossal structure built around a star to capture most of its energy. Another possibility is moving Earth's orbit outward using gravitational assists from asteroids, slowly shifting the planet away from the expanding sun. Advanced civilizations could also colonize distant star systems, transforming humanity into a multiplanetary species. If our descendants reach this level of technology, the death of the sun would not mean the death of humanity. Instead, it would simply mark the end of one chapter in our cosmic journey. However, such survival requires unprecedented cooperation, technological growth, and long-term stability. Long before the sun becomes dangerous, humanity must first overcome its own internal challenges: climate change, resource depletion, conflict, and environmental destruction. The irony is that while the sun's destruction lies billions of years in the future, human actions could make Earth uninhabitable within just a few centuries. In cosmic terms, our entire civilization has existed for the blink of an eye. All recorded human history occupies less than 1/1,000,000th of the sun's lifespan. And yet, during this tiny window, we have developed science, language, technology, art, and the ability to understand our own cosmic destiny. We are a species capable of looking at the stars and predicting the death of our own sun. That alone is extraordinary. Every sunrise you witness is powered by nuclear reactions occurring deep inside a star 150 million kilometers away. Every breath you take is possible because of energy that began its journey millions of years ago in the sun's core. Life on Earth is not permanent. It is a fragile, temporary phenomenon balanced delicately between gravity and nuclear fire. When you step outside and feel sunlight on your skin, remember that you are experiencing one of the rarest gifts in the universe: life during the stable years of a star. Most planets are either frozen wastelands or burning infernos. Very few exist in this narrow window where life can flourish. Earth does, and that makes this moment incredibly precious. One day, far in the future, when the sun swells into a red giant and Earth disappears, no memory of humanity may remain. No monuments, no cities, no oceans, no forests, only drifting particles scattered across space. But right now, in this moment, life exists, consciousness exists, curiosity exists, and we can understand our place in the universe. Right now, you are living in a cosmic miracle, in a universe filled with hundreds of billions of galaxies, each containing billions of stars and planets. Only a tiny fraction exist in conditions that allow life to survive. Earth is one of those rare worlds. And even on Earth, intelligent life capable of understanding the universe has existed for only a microscopic moment in cosmic time. This moment, this era, this fragile window of stability is incredibly precious. However, such survival requires unprecedented cooperation, technological growth, and long-term stability. Long before the sun becomes dangerous, humanity must first overcome its own internal challenges. Climate change, resource depletion, pollution, conflict, environmental destruction, and uncontrolled technological risks threaten our future far more immediately than the sun ever will. The irony is that while the sun's destruction lies billions of years in the future, human actions could make Earth uninhabitable within just a few centuries. In cosmic terms, our entire civilization has existed for the blink of an eye. All recorded human history occupies less than 1/1,000,000th of the sun's lifespan. And yet, during this tiny window, we have developed science, language, technology, art, philosophy, and the ability to understand our own cosmic destiny. We are a species capable of looking at the stars and predicting the death of our own sun. That alone is extraordinary. Every sunrise you witness is powered by nuclear reactions occurring deep inside a star 150 million kilometers away. Every breath you take is possible because of energy that began its journey millions of years ago in the sun's core. Life on Earth is not permanent. It is a fragile temporary phenomenon balanced delicately between gravity and nuclear fire. The sun is both our greatest protector and our eventual destroyer. Deep inside the sun, hydrogen atoms are constantly being crushed together under unimaginable pressure and temperature. In this nuclear furnace, hydrogen fuses into helium, releasing enormous amounts of energy. Every second, the sun converts around 600 million tons of hydrogen into pure energy. This energy radiates outward, taking thousands of years to reach the surface, and then just 8 minutes to cross the vast emptiness of space and reach Earth. This delicate balance of nuclear fusion has kept the sun stable for nearly 4.6 billion years. But nothing in the universe lasts forever. The sun is slowly changing. As it ages, its core grows denser, hotter, and more energetic. As a result, the sun is gradually becoming brighter. Right now, the sun is about 30% brighter than it was when life first began on Earth. And this brightness is still increasing. In about 1 billion years, the sun will be roughly 10% brighter than it is today. That might sound small, but for Earth, this change will be catastrophic. A 10% increase in solar brightness will drastically disrupt Earth's climate. Global temperatures will rise. The oceans will begin to evaporate faster than rainfall can replenish them. The atmosphere will fill with water vapor, a powerful greenhouse gas, trapping even more heat. This runaway greenhouse effect will accelerate warming until Earth begins to resemble a slow-burning oven. Plants will struggle to survive as carbon dioxide levels drop. Photosynthesis will fail, oxygen production will collapse. As oxygen levels fall, complex life forms will suffocate. Animals will disappear, forests will vanish. The biosphere will collapse. Earth will slowly transform into a hostile world dominated by microbial life, if any life remains at all. Long before the sun becomes a red giant, Earth will already be nearly lifeless. The oceans will shrink, continents will dry out, massive desert regions will spread across the planet. Rainfall will become rare, rivers will vanish. The blue planet will fade into a dull brown world. Eventually, Earth's surface temperature will exceed the boiling point of water. The remaining oceans will evaporate into space. Ultraviolet radiation from the sun will break apart water molecules in the upper atmosphere. Hydrogen will escape into space. Oxygen will react with surface minerals. Slowly, permanently, Earth will lose its water forever. At this stage, Earth will resemble Venus, a scorching, airless, lifeless wasteland. The world that once hosted forests, oceans, animals, and civilizations will become a silent desert, orbiting a slowly aging star. But the sun's transformation is far from complete. Around 5 billion years from now, the sun will exhaust most of its hydrogen fuel. Without sufficient nuclear fusion to counteract gravity, The sun's core will collapse inward. This collapse will ignite a new phase of fusion involving helium. The outer layers of the sun will expand outward dramatically. The sun will enter its red giant phase. During this transformation, the sun will grow more than 100 times its current size. Its outer atmosphere will stretch far beyond the orbit of Mercury, likely engulfing Venus and possibly Earth. As the red giant sun expands, its surface temperature will decrease, giving it a deep orange-red glow. But despite appearing cooler, its total energy output will skyrocket. Earth's surface temperatures will reach thousands of degrees Celsius. Mountains will melt, the crust will liquefy. The atmosphere will be stripped away. Any remaining traces of life will be erased. If Earth avoids being physically swallowed by the expanding sun, it will still be completely sterilized, transformed into molten rock and drifting debris. Eventually, the sun will shed its outer layers into space, forming a beautiful planetary nebula. At its center, a dense white dwarf will remain, the hot, glowing core of the former sun. This white dwarf will slowly cool over trillions of years, fading into darkness. The once brilliant sun will become a cold, dead stellar ember. And Earth, once alive, once vibrant, once conscious, will be gone. Yet, the story does not necessarily end there. Humanity, if it survives long enough, may escape this fate. Long before the sun becomes deadly, advanced civilizations could colonize distant planets, build artificial habitats in space, and create technologies capable of sustaining life independent of stars. Massive rotating space stations could house millions of people. Artificial stars could provide controlled fusion energy. Interstellar travel could allow humans to migrate between solar systems. Some scientists believe humanity may one day become a multi-planetary species, spreading across the galaxy. Others imagine self-sustaining digital civilizations, where consciousness exists inside vast computational structures powered by stellar energy. If such futures become reality, the death of the sun would not mean the end of human existence. Instead, it would simply mark the closing of one chapter in a far greater cosmic story. However, all of this depends on one critical factor: survival through our own technological adolescence. Right now, humanity faces unprecedented challenges. Climate change threatens ecosystems, nuclear weapons threaten civilization. Artificial intelligence, biotechnology, and advanced engineering carry both enormous promise and existential risk. Our future depends on wisdom, cooperation, and long-term thinking. The universe has granted us a brief moment of stability, a tiny island of calm between cosmic chaos. How we use this moment will determine whether we fade into extinction or rise into a spacefaring civilization. When you step outside and feel sunlight on your skin, remember that you are experiencing one of the rarest gifts in the universe: life during the stable years of a star. Most planets are either frozen wastelands or burning infernos. Very few exist in this narrow window where life can flourish. Earth does, and that makes this moment incredibly precious. One day, far in the future, when the sun swells into a red giant and Earth disappears, no memory of humanity may remain. No monuments, no cities, no oceans, no forests. Only drifting particles scattered across space. But right now, in this moment, life exists. Consciousness exists. Curiosity exists. And we can understand our place in the universe. We are stardust that learn to think. Atoms forged in ancient stars, now capable of exploring the cosmos and predicting the death of our own sun. This awareness is perhaps the most extraordinary achievement of life. The universe does not promise permanence. It offers only brief windows of opportunity. Earth is one such window. Humanity is another. What we become before the sun destroys life on Earth will define our ultimate legacy in the cosmos. This is Infinite Cosmos, and this is the true story of when and how the sun will destroy life on Earth.